There it goes.
Okay. So yeah, it is recording. Or
Now
did
it
it?
is, yep.
Okay. So up to this point, it wasn't recording?
I don't think so, but
Okay.
we didn't really get into anything. So.
Oh, we didn't really. Thanks for letting me know. All right. Today we're doing 11.3. Wednesday we're doing assembly and recursion. It's the last of our selected topics, and you have the calendar to know when that's coming up. Today we're going to get into binary files. Binary files are files that the computer can work with a lot easier. Up to this point, we've worked with text files. Text files were nice because we could create them if we wanted. We could easily open them to um, edit them if we wanted, and we could also open them quickly to see what the output looks like. And it's nice because it's permanent storage for the input and the output. One of the things that happens though with the text file is we have to do conversions. And if you have large sets of data, the conversions could take a lot of time. So what we're going to take a look at today are binary files. When we read and write our data to our files, it's going to be written as binary and read as binary, and it's not going to be so easy to read if you open it up in a text file. Sometimes you can open it up and see, you get the gist of what's going on in some things, but we're also using simple text. We're not getting into a lot of writing big data at this point. So we're going to start by taking a look at binary files, and you had a code listing or two. The first one was 1113. So I'm going to switch screens here and go over, and then I'm going to start to share my screen. And I want to share, I don't see it. Da, 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 da. Let me do this once. Exit full screen. If I share this screen, you see what looks like D2L.
Yeah.
Okay, good. So the first code listing you had was to write to a binary file. And taking a look at that, dude, I had it all keyed up earlier. So what do I have? I have a program. First thing I always do is look at the imports. No new import statements, just the Java IO, which is good. Line 10 is interesting. Again, you starting to get oh, there's that throws IO exception that we recently talked about. I'm working with files. I still have to have the throws IO exception. Looks like I have a bunch of dummy numbers stored in an array. And what do I want to do? I want to create a file output stream object. It's good. The object's going to be called fstream. And then I'm going to wrap the data output stream around it. And I'm going to say output file. Whenever I reference output file, it's going to work with numbers.dat. As you know from before, if I'm getting ready to write to a file, if it doesn't exist, it creates it. If it does exist, it's going to erase it and put a thing called a file pointer at the very beginning so that it can get ready to write to a file. Now, how do you know that this is a binary file? Well, the reason is the file output stream that we have and the data output stream. Two different classes that we're working with that are going to help us to write a binary file. Now, after you do that, you do the write, everything looks normal. Line 25 though, we're going to do something where we say output file dot write int, because we're writing an integer. It needs to know that it's working with integers. It needs to know how to store it in memory. It needs to know that it's going to be integers. So when I get ready to read, I also need to know that it's going to be integers so I know what size block of memory to be reading when I read the file. So if you ran this, I think mine is in downloads, and let's see if I can get at this. I can't get at it, believe it or not. File run. Let's go old school since my run is blocked. Where's run? Down in project, build. I haven't done it so long. And for those of you that may have heard the terminology before or not, this is called a batch file. Why? Because you're not interacting at all. All you do is run it. It takes care of itself and creates a batch program. If I go into downloads, I see my data file that was created. I'm going to open it and see that it looks like, does it look like what was in the array? 2, 4, oh, geez, and crap. Anyhow, you hopefully were able to do it, correct? Yes, good. Thank you. Thank you. So continuing to work with binary files, the next program that I wanted to take a look at was write binary file. So I'm going to have to go back up here and find my, or excuse me, read binary file. Do, 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 do. Do, 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 do. And again, same kind of things going on. I do a throws IO exception. I wrap the object from file input stream. I wrap it with data input stream. So I know I'm working with binary files. And this time I need to know what I'm reading. So throwing it in a little try block, getting fancy, refreshing what we've done before. And you notice in line 24, I say number equals input file dot read int. Now there's a table 11.1. Hopefully you looked over it because you would see that it includes all of the methods like read int, read byte, and so on. How do I work with a string? It would be write and read what? Bueller?
UTF.
UTF, thank you. UTF. So it's a little bit, go ahead.
Sorry, those are split across table 11.1 and 2.
11.1 is the write, 11.2 would be the read. And then you had another code listing to type in that was code listing 11.4, and that was reading from a binary file. And I don't think there are any questions on it. Again, it has some stuff with a while, a try, and a catch. Questions, comments? Okay, let me get out of here. Let me get back to where I don't know. Not that one. This one. Uh-oh, don't want to do that, do I? Why is it not? I'm going to stop sharing. Excuse me. Okay, now you're back to seeing me, correct?
Yes.
And I'm going to jump over to this guy, and let's see what's going on. Okay, so the first thing we talked about today is a binary file. It's a little bit different than a text file because it saves it as a whole bunch of garbage. Did anybody read through and see what this saves it as, a term that was in there? It saves it in, okay, raw binary format. Term you might hear, RBF might be an extension that you see. Okay, second thing we're going to talk about today, another way, and the program I'm going to give you to work on in a little bit is going to deal with these random access files. Okay, now random access file, it's going to be a file where everything that we've done so far with files has been extremely linear. If I want to work with the file, I start in the beginning and I go to the end. But a random access file is going to allow me to take a file pointer and move it. So when I get ready and open up a file to read, I have the file pointer and it sits at the beginning. But what if I didn't want to be sequential, start at the beginning and go all the way to the end. What if I wanted to be able to jump around? What if I wanted to say, okay, I know the location of where I'd like to be. I'd like to jump there. Or what if I wanted to go back? So I want to be able to use this file pointer and help it to allow me to, for better words, excuse me, to be able to jump around. You were writing a code listing. It was 11.15, and we're going to take a look at that in a minute. It was called write letters. And we're going to take a look at how this random access file works. Okay? Comments, questions? All right, so going back up to my terminology, this file pointer, we're going to take a look at how this jumps around. Now, I know by now, if I deal with a character is going to take up 2 bytes. So if this is 0 and this is 1, a character is going to be stored in a combination of those 2. So this would be my first character. If I wanted to get to my second character, I'd have to go to location 2 and 3 to find out where it was. If I wanted to get to the third character, I'd have to go 2 more bytes, 4 and 5. So using this file pointer, I'm going to tell it how I'd like it to jump around, to go to a certain location, to move 2 bytes at a time. So what is it I'm taking a look at? What if I have a file and the file name is, for example, random file, and I want to use a method called seek, which was going to allow me to jump around, and I could go to, say I wanted to go and get the third character, I would seek and move it over to 4. Why? Because I'm storing characters, so they're 2 bytes at a time, 2 bytes at a time, and they're going to continue to move me over. At that point, I could take my random file if I really wanted to, and I could read the character at that location. So everybody got the idea of what's going on?
Yeah, I think so.
Okay. In your books, I'd like you to go to code listing. Why am I writing 1115 down? I don't want that. I want 1116. So on page 743, I'm taking a look at code listing 1116. Now I start thinking, what lines are important? I'm looking at line 18 and 19. So now I'm getting ready to work with my file. I call a new class random access file. I get an object I'm going to call random file, and I start to take a look at new random file, what the name of it is, followed by an R. Okay, so I have 2 important parameters that I'm going to pass in. One is R, and the other one is RW. Now, the R is going to allow me to read from a file. What R will do is, again, like any other file we've worked with, if it doesn't exist, it'll create it. If it does exist, it'll wipe everything out and put the file pointer at the very beginning. RW allows me to read and write. It's going to allow me to jump around. So RW is one that you're going to work with a lot. R is one you work with if you don't want somebody screwing up the file. You only set it so that it can be read from. So this RW is going to come into play in a little bit. But I'm still looking at 1116. I have the R, and I go through, and in this case, I'm working with characters. And what you notice is I set a constant variable called char size to be 2, so that I know when I'm moving around, it's going to jump 2 at a time. Like as I explained up above, the first character is at location 0. If I'm going to be working with a random access file, I have to move by the bytes. I'm going to need to jump over here to 2, or to the next one, 3. So to get the location of the third one, it's at 4. To get the location of the fourth one, it's at 6. to get the location of the nth one, where would it be? If I had to come up with a little formula, what would it be? If I want the nth character, where is it? At what memory location?
Quantity n minus 1 times 2.
Yep, 2 times the quantity n minus 1. If I throw, I want the fourth one, that's 2 times 3, it's up at 6. So, you know, don't ever lose your math skills when you're working with this, because sometimes you're counting, sometimes, you know, there's different things going on. But keep the math knowledge, because it may make things easier down the road. All right, back to this 11:16. I want to go and I can move the pointer. Line 24 is moving the pointer over. And what's going to happen at 24? I just get ready and I read what's there. In this case, F is there. If I want to move down somewhere else, you take a look at lines 34, 35. We're reading in a character and printing it out. So there's different ways to move and read char. What if I wanted to replace something? Well, I could move it and do a write char, and it would make that go into that actual file at that position. Okay. I could also use this random access file linearly in case I want to read something, or if I wanted to go through and change all of the 8s to 11s, you know, I would use the linear approach instead of the seek and locate approach. Comments, questions? Still doing okay? All right, let's go see if I can get this right quicker. I want to go back to the camera. I want to go and share screen, and I want to share my screen, and we're here and I don't see what I want to. So I'm going to go into news and here we go. That's not November 6th. So I'm going to edit this. I'm going to make it Monday, April 6th. Sorry about that, folks. I'm usually more on top of this. I'm going to make this now. And it's a file that you should be able to see on D2L on your own. I go to course home. I say, okay, what do I have? Attached is a random access file, okay? I want you to create a file to store the following information. You see this line? PLPRPN WPPKS da 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 da. So you're going to use write letters to write these letters to a data file. Okay? Easy enough?
Mm-hmm.
Okay. Then I want you to open up the random access file. This is a separate program. I want you to open it in RW mode so that we can read and write. And I want you to go through, and wherever there is a P, so you need to read it. If it equals a P, I want you to write an E. Wherever there's a Q, I want you to write an A. Wherever there's a Z, I want you to write an O. Then the second thing I want you to do is use seek and replace the 4th character with a V, the 16th character with a W, the 21st with a D, the 26th with an R. Then I want you to close it. Then I want you to write technically a third, because we have the first program I'm giving you to write all this to a binary file. The second one, you're going to open it up and write a program to make all these changes. The third one, you're going to open it up and display what was in the random access file. Questions? And then you'll be able to see what it says. All right, so how many folks do we have in here today? I'm changing it 3, 4, 5, 3, 6, 8. 3, 6, 8 out of 11. Matthew showed up. So Leah, Brian, and Jake. I'm going to put you in, let's see, you have 25 minutes. I'm going to put you in pairs because I think you can do this in pairs. So I need to go to breakout rooms. I need to have how many of them? 4 of them. So I'm going to, I'm going to close all rooms. I'm going to come back up and I'm going to delete this one. And now I'm going to close that. Now I'm going to come back. My last class, they were hanging out for a long time. Recreate. Boom. You're going to all be in rooms and I'll be around to visit. Any questions? Okie doke. Here we go.